Aloha, everybody. Try this again this morning. Hopefully I can get it to work. I've had a little bit of trouble. I think I'm going to go old school and use this old computer. I got an old Chromebook for kids, and I'm going to try this for a while and cross your fingers. And hopefully we don't have any interruptions in our homework videos or our warm-ups for a while. So let's get this go. I'm not sure how much of what we've already done you missed. So I'm just going to review a little bit. This last diamond at 1/2 times 1/4. Remember, multiplying fractions is easy, and the reason is you don't have to worry about common denominators. You just multiply straight across the top, 1 times 1. Straight across the bottom, that's 2 times 4, and that's 8, so 1/8. When you add, you do have to worry about having a common denominator, and we're lucky here because 2 goes into 4. I can change these to fourths, which means I don't have to change this 1. So we're doing half the work there, right? I just have to change 1/2 to 2/4, and now I have 1/2 plus, or 1/2 is just 2/4, plus 1/4 equals 3/4. That's why that works, okay? Reminder, when we do these integer problems, I've been told by many students that they think the easiest way, and I got to agree with them, to keep yourself from getting confused and getting these wrongs is to remember that subtracting a number is the same as adding its opposite. So with all of the subtraction problems with integers, just do a quick little extra step, takes about 5 seconds, and turn it into an addition problem by adding the opposite. Now again, the first number you're dealing with does not change when you do this. That -18 minus 8, the -18 is going to stay the same. Don't mess with that first number. But instead of subtracting a number, I'm going to add its opposite. Instead of subtracting 8, I'm going to add -8. Instead of subtracting -3, I'm going to add +3. Okay? I think this will help you a lot, keep you from getting some of these wrong, which you would get right. After that point, when I'm adding, I always think when I'm adding integers, I always think of money. I have $18 plus I owe $8. So I have more than I owe, right? I'm going to pay that 8 out of this 18. I will still have 10 left. Okay? I owe 18 plus I have 8. I can pay this 8 that I have, but it's not enough. I'm still going to owe some. How much will I still owe? I will still owe 10. Okay? Now on this one, I owe 18 minus 8. That's confusing to me, so I changed it into the adding the opposite. I owe 18 plus I owe 8. I owe a bunch. How much? I owe 26. Okay, and then we get to a point where we have 14 minus 3, and that gets confusing, right? It's something you've been doing since first grade, right? 14, take away 3 is 11. Okay, sometimes when people are dealing with this, they still go do this. They still go change it to adding the opposite. I have 14, I owe 3. I'm going to pay that 3 out of this 14. I'm still going to have 11. I owe 14 plus I have 3. That's not owing more, right? I shouldn't owe 17 when I'm done. That's a popular wrong answer. I have $3. I'm going to pay that $3. It's not enough to pay off this 14, but now I only owe 11. Here's a subtracting a negative. That's confusing, so let's instead turn it into adding the opposite. Now this -14 minus -3, okay, now turns into -14 plus 3. I'm going to pay that 3. I'm still going to owe 11. I owe 10, but I have 4. I could pay 4. It's not enough, but I don't owe as much anymore. Now I only owe 6. 10 minus 4, 6. -10 minus 4, that's confusing, so I'm going to change it into adding the opposite. Instead of minus 4, I'm going to add -4. I owe 10, plus I owe 4 more. That's a total of owing 14. How'd you do on those? Okay, hopefully you're good. Take some practice. You can't learn. If this is all you've done with adding and subtracting integers and you don't get it, you got to make sure you say, I don't get it yet. You got to practice. You're not hitting home runs on the third practice of T-ball, right? You got to take some swings, all right? Swing for the fence. Keep practicing, and you keep getting better. Okay, every problem you do makes you a little smarter. Okay, All right, on to these writing expressions. Remember, the length of this line is this x plus x plus x plus x plus 3. There it is. And this x plus x plus x plus x, I rewrote that as 4 times x. And in 8th grade, you're going to write 4 times x, just 4x. 4x plus 3 is the length of that line. How long is this line? Well, it's 17.2 plus a. Now, in general, they like to have the variable with the highest power first. So if you had like x to the 3rd power plus 2x squared plus 3x, and then the number last. Okay, so I'm going to rewrite this. It equals the same thing. 17 and 2/10 plus a is the same as a plus 17 and 2/10. But for some reason, they let the variable go first. And if you have more than one variable, it's the variable with the highest power go first, if you're adding, right? Okay, all right, what do I have here? I have b plus 3 plus f plus 4. Okay, now I'm going to go ahead and combine that 3 and 4, right? I can write b plus f plus 3 plus 4, and I'm going to combine that 3 and 4 and make it a 7. Okay, now I'm also going to combine the b plus b and call that 2 times b. So to be, or not to be, that is the question, sorry, plus f plus 7 is this length of this line in an algebraic expression simplified as much as I can. Now, if I knew what b was or I knew what f was, I could substitute and I could simplify it even further. But this is all I got right now, and that's fine. Okay? All right. Next one, m plus p plus 12. Can I combine that m and m? Yes, I can. Give me a bag of M&Ms. 2m plus p plus 12. Okay, j plus 3/4 plus j. I'm going to combine those two j's. J plus j is the same as 2 times j. So 2j plus 3/4 is the length of that line. Okay, take some practice. We'll get more. Okay, on to our portions webs. Remember, the fraction goes there. How do I turn a fraction into a decimal? Hopefully you're thinking divide the bottom into the top. So 5/8, I'm going to divide the 8 into the 5. But it won't fit, Mr. Daniel. No, of course not, unless it's improper. So what do? Well, I add a decimal. That's what I want anyway. I want a decimal. Add a decimal and add a 0, because 5 is the same as 5.0. Now 8 goes into 56 times, because that's 48. I get a remainder. What do? Add another 0. 5 is the same as 5.0, is the same as 5.0000, right? So 8 goes into 20 twice, because that's 16. I get a remainder, add another 0, and here is the last time I have to add a 0, because 8 goes into 40 evenly, right? So this ends up being 625 thousandths, 0.625. And again, the easiest thing in the world to do is to change a decimal to a percent. You just move the decimal 2 spots. If I move it 2 spots, it's between the 2 and the 5, 62.5%. What does 5/8 look like when you write it in words? 5. Now I'm going to go 8/8. I'm not sure if I spelled that right. Yeah, I could draw a picture though. I'm a math teacher, right? Okay, there is 4ths, and I cut those in half. Now it's 8ths. 4/8 is a half. One more 1/8 is 5/8. Okay, 6/10 is 6/10. Can I simplify it? Yes, both of those numbers are even. So you want to simplify if you can. 2 goes into 6 3 times, and 2 goes into 10 5 times. So I'm going to have 3/5 here. Fifths are a little bit harder to draw. Okay, and I'm going to shade in 3 of them. Okay, and again, move it 2 spots. End up with 60%. 125%, that's more than 1. Move it 2 spots, it's 1.25. That's 1 and 25 hundredths. Now, what number goes into 25 and 100? Yeah, 5, but is there a bigger number? Yeah, I almost always check to see if the small number fits in the big number. 25 fits into 100, right? How many times? 4 times. This is 1 1/4. That's the whole enchilada plus 1/4 of the enchiladas. Can't tell I ate enchiladas last night for dinner, can you? Weirdest thing, though, the can said it was red sauce and it was green sauce. Didn't matter. It's still yummy. Hey, aloha, everybody. Hopefully you got most of these. And if you didn't, hopefully you learned how to do these. So next time, if you had the same problem, you'd be able to do it. You go have a great day, all right? Talk to you soon.